Hello and welcome to Chapter 3, Properties of Logarithms. We're going to begin with the concept of the change of base formula. Now the change of base formula becomes so important because I just can't plug every logarithm into a calculator. I just can't. The calculator gives me log base 10. When I punch the button on the calculator, it gives me log base 10, or if I punch the natural log button, it gives me log base of e. What the properties of logarithm, what the change of base formula allows me to do, is it allows me to rewrite the logarithm in such a way that it is in base 10 or base e, and I can plug it into the calculator and solve. So let a, b, and x be positive real numbers such that a and b are not equal to 1. So then it can be converted to the following bases as follows. So if I want to just say some random base b, I can rewrite log base a of x to be log base b of x divided by log base b of a. If I wanted to write it in base 10, I could write it as log base 10 of x, or log x over log a, because there's an understood 10 there. If I wanted to do it in terms of natural log, I could do natural log of x over natural log of a. What basically happens is whatever this log, that's a highlighter, whatever this is that's written, log base a of x, I can just simply rewrite it as log and log, and the argument goes to the top and the base goes to the denominator. And now I can instantly plug it into a calculator and solve. Okay? Let's take a look at this first one. So log base 4 of 25. Well, I can immediately rewrite this to log base 10 of 25 divided by the log base 10 of 4, or just log 25 over log 4. I punch those into a calculator and I simplify it. You could also rewrite it into your calculator as log 25 divided by log 4. That's all you're doing there. So this becomes a very simple way to solve complex logarithms. Log base 2 of 12 becomes log 12 over log 2. Punch it in the calculator and you get your answer. It's as simple as that. With natural logarithms, I do the same thing, except now I put it natural log. Natural log of 25 over the natural log of 4. Natural log of 12 over the natural log of 2. Notice, what do I notice between the answers up here and the answers down here? Well, they're the same thing. You're going to get the same answer. It doesn't matter which one you use. I get that question every year. Well, does it matter if I do natural log or log? No. I know some kids, if they just think the natural log is cool, they want to use the natural log. I'm okay with that. You're in the natural log fan club. Hey, that's a very natural thing to do. Okay? So some properties of logarithms. These are very important. Product quotient and power property. I talked about the power property briefly in the last lesson, but let a be positive numbers such that a does not equal 1, and let n be real number, and if u and v are positive real numbers, then these properties are true. The product property basically says if I have the log base a of two numbers that are multiplied together, then I can rewrite them as log base a of u plus log base a of v. And I can do the same thing as if they're natural logs. The natural log of u times v is the natural log of u plus the natural log of v. The quotient property says if I have log base a of u over v, then it's the same thing as log base a of u minus log base a of v. And likewise with the natural logarithm. Natural logarithm of u divided by v is the natural logarithm of u minus the natural logarithm of v. Now the power property says that if I have log base a of u to the n power, if I have as my argument of my logarithm something such that it has an exponent with it, I can basically roll off the log, is what we used to call it, for a log or natural log. So I can take that exponent, roll it off the log, and put it on the front. That can be beneficial sometimes because if I have log base 3 of 5 to the x power, I can roll off the x to the front of it and then do log 5 divided by log 3 and solve. So using properties of logarithms, write each of these in terms of log 2 and log 3. Well, I asked myself on the first one, I've got the natural log of 6. Well, what times what equals 6? Well, I could say that the natural log of 2 times the natural log of, or 2 times 3. Now remember from my product property up here is that if I have two things multiplied in the argument of the logarithm, then I can call it like this and that. And now it is written in terms of natural log of 2 and natural log of 3. On the next one, I have a quotient. This is a quotient property. So the natural log of 2 over 27, well, I need to get 20. I've got 2. That works for me. But let's break it apart. Let's break it apart. Natural log of 2 minus the natural log of 27. But I need to get that 27 down. Well, if I want to get it down in terms of a power of 3, I know that 3 to the third power is 27. Because 3 times 3 is 9, and 9 times 3 is 27. Now, I'm not done yet. I want it in terms of natural log of 3, not the natural log of 3 cubed. So now I'm going to use my third rule, the power rule, to roll it off the log. So I get the natural log of 2 minus 3 times the natural log of 3. So what I've done is I've taken these and I've rewritten them in the terms of another logarithm. So find the exact value of the expression without using the calculator. Well, let's just let's see what we've got here. Well, I know that if I have the cubed root of 5, then I've got log base 5 of 5 to the 1/3 power. Let's roll off the log. So I get log base 5 of 5. Well, I have the same base as I do argument, so that just becomes 1. So I just get 1/3. In the next one, I've got the natural log of e to the 6 minus the natural log of e to the 2nd power. Let's roll off the log of each of those. So I've got the natural log of e to the 6 minus the natural log of e to the 2nd. I'm going to roll off the log. So I get 6 times the natural log of e minus 2 times the natural log of e. Well, I remember from my rules before that if I have the natural log of e, that is the same thing as saying log base e of e. So that just is 1. So I get 6 times 1 minus 2 times 1. 4 is my answer. So I was able to evaluate that without using a calculator. Now, if I had used a calculator, I'd get the same thing. So expand the logarithmic expression. So now, instead of, I'm going to take it from a condensed format, and I'm going to expand it out. What I mean by expanded is I want to use product, quotient, and power rule to make it as long as possible. And you will have assignment problems based on this. So I have base 4. So the first thing I'm going to do is I'm going to use the product rule because I've got a whole bunch of multiplication. So I'm going to have log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. I'm going to take this 3 and I'm going to roll it off the log because of the power property. Log base 4 of 5 plus 3 times log base 4 of x plus log base 4 of y. And that's expanded as much as I can get. I can't do it any more than that. Technically, I could solve log base 4 of 5, but that's not expanding, that's solving, and the questions didn't ask for that. Next, I've got the natural log of square root of 3x minus 5 over 7. Well, first I'm going to use the quotient rule to rewrite it as the natural log of the square root of 3x minus 5 minus the natural log of 7. Okay, I've got that square root there. I need to rewrite the square root in exponential format. So I've got the natural log of quantity, 3x minus 5 to the 1/2 power minus the natural log of 7. I've got an exponent, so I'm going to roll it off the log. I get 1/2, the natural log of 3x minus 5 minus the natural log of 7. And that's about as much as I can do. I can't really do anything more beyond that. Okay, condense each of these. So now I'm going to take them, and I'm going to take them from the expanded, I'm going to shrink them. So when I have 1/2 log base x plus 3 log of x plus 1. What I need to do here is I need to roll these numbers on the outside back on before I can reverse things. So now I'm going to go in reverse. So I'm going to have log base x to the 1/2 plus log of x plus 1 to the 3rd power. Okay, now I'm going to do a reverse product rule. I'm going to have log of x to the 1/2 power times x plus 1 cubed. Let's take that 1/2 power, and for the fun of it, make it the square root of x times x plus 1 cubed. I'm not going to ask you to do x plus 1 cubed. Okay, you have sufficiently condensed it. Get a different color. Let's go with green. So now I'm going to take 2 times the natural log of x plus 2 minus the natural log of x. So 2 times the natural log of x plus 2 minus the natural log of x. I'm going to roll it back on the log. So I get the natural log of x plus 2 squared minus the natural log of x. And do a reverse quotient. Natural log of x plus 2 squared over x. Finally, I'm going to do 1/3 log base 2 of x log base 2 of x plus 1. Now, at first glance, you may think, oh, well, let's just roll that on. I can't do that because technically it's being multiplied by a parentheses or bracket. It's not being multiplied by a log yet. So what I'm going to do is I'm going to multiply it through, distribute the 1/3 through, then I can go ahead and roll it back on the log. So I'll get log base 2 of x to the 1/3 plus log base 2 of x plus 1 to the 1/3. Now I can do a reverse product of x to the 1/3 times x plus 1 to the 1/3. And I'm not going to ask you to take x plus 1 and try to, no. Okay, you're good to go. Technically, there is one more step we can do. Let's put these into cubed root of x times the cubed root of x plus 1. And then I can technically multiply them together because they have the same power, like so. And that would be as far as I can go. And that concludes today's lesson.